All right, so let's talk about logarithms. Okay, so taking a log of a number, or logarithm of a number, is just the inverse process of raising a number to an exponent. So what do I mean? So let's say that we have log base b of x is equal to y. Okay, so again, you need to get used to reading this. Log base b of x equals y. What this means, and this little symbol here just means that these two are equivalent. So log base b of x equals y is the same thing as saying b to the y equals x. B to the y equals x. So when you see this, all you should do in your mind is just say b raised to the y equals x. And you've got it. So let's look at some examples. So here I have log base b of x equals y. There's an understood y over there. So what does this mean? It means 2 raised to this number equals 8. So 2 raised to what number gives me 8? Well, that would be 3. So see, it's just the inverse process. Previous lesson, you figured out 2 to the third is what? Now you're just figuring out 2 raised to what number gives you 8. All right, let's try another. So log base 3 of 9. So 3 raised to what number gives me 9? Well, that's a 2. 3 squared is 9. So it's really easy. All right, let's make it more interesting now. So log base 4 of 1 over 64. All right, so 4 raised to what number will get me 1 over 64? So there's two things going on here. First, how do you turn a 4 into a 64? Well, 4 to the third power gives me 64. 4 times 4 times 4 is 64. But I want it to be 1 over 64. So how do we get the numbers to flip? We raise to a negative exponent. So this would be negative 3. 4 to the negative third power is 1 over 64. All right, log base 9 of 3. So 9 raised to what power gives me 3? Well, to turn a 9 into a 3, I have to take the square root of it. So I need to raise 9 to the 1/2 power. 9 raised to the 1/2 power is 3. All right, now let's do a really challenging one, and they really don't get any harder than this. Let's do log base 125 of 1 over 25. All right, so how do I turn a 125 into a 25? So you got to kind of think about, what do those have in common? What do they have to do with each other? Well, we've done enough examples now that you know 5 to the third power is 125. So you know that if you took the cube root of 125, you would get a 5. And then you know how to turn a 5 into a 25. You square it. Okay, so if I want the cube root of 125, I need a 3 in the denominator. That gets me the cube root of 125, which would be 5. Then I need to square a 5, so I'm going to need a 2 in the numerator. That gets me my 25. But I want it to be 1 over 25, so my exponent needs to be negative. So if you can do this one, you can do any of them. Let's double check what we've done here. So I'm claiming that 125 raised to the negative 2/3 power should equal 1 over 25. Okay, does it? So 125 to the negative 2/3 power. We have a 3 in the denominator, so that's the cube root of 125. 2 in the numerator, and it's an exponent, so it's 1 over that. Cube root of 125 is 5. 5 squared really is 25. So that is correct. All right, so let's do log base 10 of 1,000. Before we figure out the answer, though, I want to point out that this is a really common logarithm. We like to use base 10 a lot. So people have made an abbreviation for this. So it's so common, and it's actually called the common log, that we're just going to not write the base. Okay, so we're just going to do this, log of 1,000. Okay. So if you just see a log without a base, it means base 10. So there's an understood 10 right here. All right, so what is log of 1,000? So there's an understood 10 here. So 10 raised to what power gives me 1,000? So obviously that's a 3. There's 3 zeros there. All right, let's do one more of those. Let's do the log of 0.01. So the log of 0.01. The understood base is 10. So that's the first thing you need to get straight in your head. You can even write it in if you want. Understood base is 10. All right, 0.01. What's 0.01 as a fraction? So that's the tenths place, hundredths place, so that's 1 over 100. All right, so 10 raised to what power gives me 1 over 100? So obviously it's going to be negative because it gets flipped upside down, and I have to square 10 to get 100. So my answer would be -2. All right, here's another good one. Log base e. And let's say that we have 1. Log base e of 1. All right. This one is also very popular. Log base e gets used all the time, so it has an abbreviation. It's abbreviated the natural log. Okay. And that's an L. It's LN. Okay, a lowercase l. So this stands for natural log. I don't know why the L comes before the N. I think it's French or something. So LN means natural log. Okay, I'll even write that out for you. That is the natural log. Okay, so if you see an LN, all that means is log base e. All right, so what is a log base e of 1? So e raised to what power gives me 1? Well, that would be 0. Right? E to the 0 is 1. All right, let's try another. So let's do the natural log of e to the 3rd. All right. I write my LNs in cursive. Nobody else does that. That's just LN. It's a cursive LN. I don't know why I do that. You'll see it printed on paper. All right, so what's the natural log of e to the 3rd? So in your mind, when you see natural log, just remember that that's log base e of e to the 3rd. All right, so e raised to what power gives me e to the 3rd? Well, that would be a 3. E to the 3rd is e to the 3rd. All right, let's do this. What's log base 2 of 0? All right, so 2 raised to what number gives me 0? Well, you can't raise 2 to any number and get 0, so that is undefined. No matter how many times you multiply 2 by itself, there's no way to get 0, so that's undefined. What about log base 2 of -8? What's that? Well, you might think just automatically that it's -3, right? 2 to the 3rd is 8, put a negative sign on it. But that's not right, because 2 to a negative exponent means 1 over. So 2 to the -3rd would be 1/8, not -8. And in fact, there's no way to get a -8 out of that. You can't raise 2 to any power and turn it into a negative. So that's undefined. So you can only take a log of positive numbers. You can't do 0, and you can't do negative numbers. All right, so let's graph this function, log base 2 of x. So let's start out with a 1. Okay, so I'm going to put a 1 in for x. What's log base 2 of 1? So 2 raised to what power gives me 1? Well, that's 0. 2 raised to the 0 power is 1. Now let's put in a 2. Right, so I'm putting in a 2 for x. So log base 2 of 2. 2 raised to what power gives me 2? Now that would be 1. 2 raised to the first power is 2. Let's put in a 4. So what's log base 2 of 4? 2 raised to what power gives me 4? That would be 2. Let's put in an 8. So if I put an 8 in for x, what's log base 2 of 8? 2 raised to what power gives me 8? That would be 3. So there's that one. Now let's put in 1/2. Okay, so right there's 1/2. So let's come over here and do it. What's log base 2 of 1/2? So 2 raised to what power gives me 1/2? Now I got to get flipped upside down, and 2 raised to the first is 2. So that would just be -1. 2 to the negative first power is 1/2. So if I plug in 1/2, I get a -1. All right, let's plug in a 1/4 right here. What's log base 2 of 1/4? 2 raised to what power gives me 1/4? That would be a -2. 2 to the negative second is 1/4. So plug in 1/4, get a -2. And I think you can see what's happening here, but let's do one more. What's log base 2 of 1/8? So we'll plug in 1/8. 2 raised to what power is 1/8? Obviously, that's -3. And you see we're going to have a vertical asymptote going down this way. The closer my x value gets to 0, the farther down my f of x value goes. So this graph looks like this, right down that asymptote. So we have this nice vertical asymptote. Notice, again, 0 is undefined. I can't plug a 0 in, and I can't plug in any negative number. So my domain is from 0 to infinity, not including the 0, so it's an open parenthesis. So from 0 to infinity is my domain. My range goes down this way forever and up this way forever. So range is from negative infinity to infinity. It's all real numbers. All right, so here on this same graph, let's graph g of x equals 2 to the x, like we did in the last lesson. So again, the initial value of this, if I plug in 0, I got 1. If I plug in 1, I get 2. If I plug in 2, I get 4. And then if I plug in 3, I get 8. Remember the graph did that. And then if I put in -1, 2 to the negative first is 1/2, 1/4, 1/8, and so on. And it went right out this horizontal asymptote. So let's think about these points. This point is 1, 0. This is 0, 1. This point is 2, 1. This one's 1, 2. This point is 4, 2. And this one's 2, 4. And the next one, we would have 3, 8. And we have 8, 3 out there. So remember what that is. These are inverse functions. Okay. And if I plotted the line y equals x, so 1, 1, 2, 2, 3, 3, and so on. This line y equals x. This graph and this graph are just reflections across the line y equals x. They are inverse functions. So on this one, we have a horizontal asymptote. Here we have a vertical asymptote. On the black one, my domain is from 0 to infinity. On this one, my range is from 0 to infinity. On the black one, my range is from negative infinity, it's all real numbers. And on this one, my domain is all real numbers. So those are inverse functions.